Hey everyone, so last time we went over how to print the Fibonacci sequence using an iterative addition. This time we're going to talk about how to do it using recursion. Now recursion is basically if you can do something iteratively, you can do it recursively. There's usually always that back and forth. If you could do it one way, you could do it another way. So with this, since we did it iteratively, we can now do it recursively. Now recursively basically means you just keep calling the method over and over and over again until you hit a breaking point. And that breaking point is usually the first thing that you would hit. So I'm going to make a public string print n items iterative and n, and I'm going to return the print n items iterative. This should not be iterative. This should be recursive, and this should be recursive. If I could spell recursive helper, and with it, I'm passing in int n, int. I'm going to be passing in n 1 1 0 and new string builder. Now I will create the private version of this, print n items recursive helper, where I have the int of items wanted, int left, int right, int count, and the string builder SB. So the string builder will be the item that have everything in it. So it will contain what we're trying to print out. So if actually string builder dot append left plus a space. If you hear my cat in the background, she came into the room and is meowing at me. She does this quite often. I wouldn't pay her any mind. So we do that. I have misspelled this method again. Then I'm just checking if items wanted equals the count. Then we return SB dot toString, which will return a string. And then what we do is otherwise we return print n items recursive helper of items wanted. We'll pass in right, we'll pass in left plus right, we'll pass in a count, and then we'll also pass in SB. And this is really how you would do the recursive setup. So if I had this correct, it should print the same thing. So if I head over to calculations, I will change this to recursive. And what I'm going to do, and then I'm just going to close my input, close my scanner, so I don't have that error anymore. So let's see, if I print out 5, I get 1 1 2 3 5 8. So I know that I'm printing out one item more than what I'm asking. So what I need to do is this needs to be a 1. And then if I run it again, print out 5, 1 1 2 3 5. So how this is working is I will pass in 5 as my number to print. Then I pass in these two starting points, which the starting point for the Fibonacci sequence is technically 1 1. So the left and the right are both 1. Then I print in or send in the count, which is the starting point where we're at. And then I create a new string builder. The new string builder will basically give me an empty string. Same thing as this line right here on line number 12, it basically just gives me an empty string builder that I can keep appending stuff to. Then I send this into my recursive helper. My recursive helper will append the left item to the string builder and add a space. And then it will check to see our breaking case of, are we hitting the breaking case of just returning the string that we want? So our breaking case is if the items wanted equals the count, then we will break. And doing this, items wanted is 5. If my count doesn't equal 5, then what I'm doing is I'm going to return this method again. And so this will keep going down into a call of itself all the way down until we hit that breaking case, and then it will come back up, returning everything that we've hit so far. And that's kind of how recursion works. You basically keep calling the method until you hit a breaking point of it, either a breaking point due to an error, and if you break a point during an error, you'll just break out of the code entirely, and that's it. That's the end of your code. It will stop execution. But if you hit a breaking point like how we have with the if block on line 31 through 33, once we hit this, that means, cool, we've hit our breaking point. Now we're going to break out of our depth. And when you break out of the depth, you come straight back up and follow suit with everything that you need to do other than your breaking point. And since the only thing that we're doing other than our breaking point is just appending to our string builder, and we do all that, and then once we hit the breaking point, we just return the toString. That's basically how recursion works. You could also think of it, we keep doing the same thing over and over and over again until we hit the breaking point. And then once we hit the breaking point, we just send back whatever we have. Or that's where we stop doing the thing over and over and over again. It's basically itself an iterative loop. But instead of having 10 lines of code, we now only have roughly 5 lines of code. You can say this is 3 lines of code. Since an if block, you can easily break that down to being 1 line of code of itself. But you can't do the same thing for like an iterative loop. You can't break that all the way down into just being 1 line. An if statement in this category, we can break this down to just be 1 line. So recursion does help minimize the amount of lines that you're doing if it is simple enough to recreate it as a recursive method compared to being an iterative method with a for loop. So next time, I'm going to show you how to use bare rolls method to get the nth item of the Fibonacci sequence. I'll see you guys next time.